Welcome to today's webinar. My name is Daniel Lang, and today we are talking about how to design and build Alexa into the Colibri with the Chatterbox AVS Development Board. The webinar today is a guest webinar from our partner Gumstix. Before we dive into the webinar, a few organizational things. We will have a live question and a session at the end of the webinar. You can already enter your question into the question box in your webinar control panel, even while the webinar is going on. It's next to the chat box. Please use this field to communicate with us, even also if you have other technical issues or you can't hear us anymore and so on. So let's start with some introduction. My name is Daniel Lang. I'm the Chief Marketing Officer for Toradex, and I work here in our office in Seattle. Today's main talk will be done by Gordon Kruber, the CEO and President of Gumstix. I also like to give you a very short 2-minute introduction of Toradex in case you're not familiar with it, and so you get a little bit of feeling with who you interface here. A fun fact is that Toradex was founded in 2003, which is actually the same year Gumstix was founded. As you can see here on the map, Toradex is present worldwide. As mentioned earlier, I'm in the office in Seattle, Washington. Headquarters are in Switzerland, and we also have local engineering, sales and support around the world. Also in all these offices we have actually a warehouse, so it makes it very easy for you to get the product independent from where you are on the world. We are very specialized on ARM-based system on module, or also called computer on modules. One of our specialities is to have a fully pin-compatible module, so you can upgrade, downgrade, or get a new module. The hardware and software development is done in-house. We support Linux and we still do Windows CE. Our software BSPs are optimized and are ready for production. We provide at least 10 years availability on our products. If you buy our product, you get actually free support for it. We have direct sales, so you always directly talk with Toradex and you don't need to deal with distributors in between. As mentioned earlier, we have the global reach, so even if you, for example, have distributed teams in different places in the world, we will be able to support them very simply. Now just a few seconds about the latest products. So the first is our Apalis iMX7 Quad-Max, which will be available later this year. But we already have an early access program, so if you think that's something for you, you can go on our website on the iMX7 Quad-Max side and sign up for updates, and we will get in touch with you and let you know how you can get into that early access program. But then today we will actually talk about our Colibri module family, and here we have an upcoming iMX8X module, which is also pin compatible, for example with the iMX7, which we use today. Here the same, the module will be available later this year. You can go on our website, sign up, and we give you more information. So now let me shortly introduce you to Gumstix. One interesting fact is that we have the same age as mentioned. But also Gumstix did actually pretty much the same thing than Toradex when they started. They did a system on modules. So you could basically say we were a competitor, and I think we were a competitor in many cases. What's a little bit different, at the beginning was Toradex focusing on Windows CE, and Gumstix did Linux from beginnings, but Toradex later also added Linux as one of our main OS we support. However, in the meantime, Gumstix began to focus more on the carrier board and create customized carrier board with a very cool online tool called Geppetto, which basically allows you to use your browser and drag and drop to create your carrier board, for example, for Colibri modules. At the moment, the tools support the Colibri iMX6 and the iMX7, which we will use in this webinar. For Toradex, it's great that we can collaborate with Gumstix and so generate value for our customer. So today we will actually use one of these carrier board created with that tool, and you will see how you can add Alexa functionality to this board. With that, I'd like to give the presentation to Gordon, who can give you more information about Gumstix and then really dig into the details and how to get Alexa running.
Good morning. Thank you very much, or good evening to those in Europe. Thank you very much, Daniel. Yes, as you said, we were competitors for many years. Gumsticks, one point in time, decided that our greatest value was in our rapid technology for deploying expansion boards reliably. And we took this automation, which includes not just hardware design, but also hardware production, documentation, and software customization for any specific expansion board or compute module, and open it up to the world as Geppetto. And it's a free online design tool to build custom hardware for either expansion boards or chip down solutions. We'll take a look at that at the end of the presentation, at a point where you've got some feel for what Chatterbox can do, which is one specific board that was designed in Geppetto to support Toradex's iMX7 Colibri. To start off, let's dive into what it is that we're going to do with Alexa. First, we're going to talk about overall AVS, not just AVS, but ASK, and I'll get into the distinction in a moment, design using Chatterbox. Specifically, we'll cover hardware, and that is the Chatterbox at this point, and how to use the Chatterbox plus the Colibri iMX7 in order to build a complete solution. The software, there are three critical components to the software. One is the Alexus Skills Kit. One is the Alexa voice services, and the third are the Linux services that run on our device that support ASK and AVS. And finally, we'll take a look at the customization so that somebody can, at the end of this, have a fair understanding of what is required in order to develop a completely custom Alexa-supported device. There are 4 steps that we're going to cover. Number 1 is covering setting up an Alexus Skills Kit. Some of these we will gloss over. We don't have a lot of time. And we will gloss over things like what to do as you create a developer account, but then we'll concentrate a little more on what it is to create a skill. And then we'll break out of the Alexa Skills Kit for a moment in order to create an IoT endpoint, which is really what the Chatterbox is. In building a Chatterbox software, it's important to start with the most recent Colibri operating system, really the most recent U-boot. So mention briefly how to update that. It's important to secure a global address so that wherever this device is, it can function behind a firewall. We'll use ngrok to do that. We'll create a responder script, which is that portion of the code which functions with the Skills Kit in order to have the Chatterbox perform some function behind a firewall. Then we'll go back to Alexa, this ASK, to complete the skill, and then we'll test the skill without using an AVS device. We'll just test the ASK using the Alexa Skills Kit test console. Thirdly, we'll set up an Alexa voice services. We'll talk about building and installing AVS device SDK. There are a few ways to do that. We'll talk about building and installing a wake word, and we'll cover briefly how to authenticate the unit, and then we'll go on and do a very brief demo. And then finally, I'll show how to customize with Geppetto. So first, let's talk about the Alexa Skills Kit. As I mentioned, the premise here is that you've gone to Amazon and you've created a developer account at Amazon, signed up for it. We will dive quickly into understanding what makes up a skill. For those of you who have not played with Alexa yet, Alexa skills are those responses or those instructions that one can give to Alexa to any Alexa device, so an Echo or an Echo Dot. And this is the back end in the cloud running at Amazon, where one identifies skills, name skills, which include a way to invoke the skills, identifies intents, really functions that can be performed by the targeted device or by Alexa. There are certain skills that can call out to Alexa, call out to other Amazon infrastructure services. And then there are slots, and any intent is covered by slots surrounded by, call them keywords or phrases. And slots you can think of as a parameter. The Amazon Skills Kit really acts to use verbal commands or questions, interpret them and parse them into what becomes a JSON request that gets sent, gets posted to some IoT endpoint that can handle the skills. We'll quickly then go through creating a skill, building the skill, and then finally we'll need to break out of playing or demoing the Alexus Skills Kit console and jump to the Chatterbox and show what we need to do with the Chatterbox to create the endpoint for it. So first off, this is after when you sign into the developer, you're given a choice of either going to the Alexus Skills Kit or to the Alexa voice service in order to get started. What we're going to do here is get started with the Alexus Skills Kit first, as discussed. And after we get started, we end up going through some sign-up procedures in order to get to creating an interaction model where we, at some point, decide what a skill invocation name is going to be. And what we have used is My Chatterbox. Something that we discovered in testing is in our own systems is if we use two-syllable words, there are too many other words that get confused that are part of or general usage in asking, for example, for the weather. But by coming up with 3 defined syllables, it worked much better, and so we just use My Chatterbox. So what we would end up saying is something along the lines of ask My Chatterbox to do something. If you look at this panel on the left here, you see that it's the interaction model we've described first in order to get to this invocation point. We described an intent, and we'll go on to the next point and discuss our intent. I just called it an instruction, or instruct is our intent. There are certain built-in intents that come with Alexa, and then after we describe our intent, we won't get into what the actions, what the slot types are, other than to describe that you can see here we've got an action, a line number, and an LED. So let's dive in to see what the intent is. Looking at, after adding, what I did was I clicked here and I added an intent that I've named instruct. And so intent instruct, this instruct here, this name is what this is here. I've given it 3 different ways in which somebody could provide here we go, a sample utterance. So for example, I've defined an action, and the actions that I defined are either the words toggle the and then LED color. So it's toggle the red light, for example. And what I've defined here are 2, either LED color is pulled from an Amazon color, which is a predefined slot type. So LED color here is slot type Amazon color. Line number here is an Amazon number. And then action is something that is a custom defined action. And I have not put a slide here for it, but in effect, it's name what we would define as an action. So it's either set, clear, or toggle. So in this case, somebody could set the red light, toggle the red light, set red, toggle red, clear red, or set, and then use the word port, and then with a line number. So somebody could say clear port 34. At that point, moving on, we can cover the interfaces or jump to the endpoint. And what we're going to have to do here is save the model and then move on. So, and what we're doing now is we're jumping over, we're leaving the Alexus Skills Kit behind. And what we're going to do is start working with our Colibri. We're going to do 3 things specifically with the Colibri in order to build it into an IoT thing, Internet of Things thing, that responds to commands from the Alexus Skills Kit. First, we're going to have to quickly configure the Colibri. Daniel, could you say 1 or 2 words about what it is to use the Toradex Easy Installer in order to bring it up to date?
Yes, so the Easy Installer is a new pre-installed software for our module. So everybody who gets a new module gets this Toradex Easy Installer, and it allows you basically with 1 click to get the latest OS and bootloader. So the system will go to our server and download the latest. And you even have choice to get pre-releases And we are now working on enabling many of our partner demos to be available as Toradex Easy Installer demos. So something pretty cool. So if you were on embedded world, so all the partner demos, most of them will be available as Toradex Easy Installer package. Also, Toradex Easy Installer is a very nice tool for volume production. So it has a lot of features which are useful for if you do your own volume production and programming.
Great, and thank you. And the key thing for us is, since individuals are likely to be putting a lot of software on here, as well as likely to be booting from a micro SD card instead of the software that comes pre-distributed from Toradex, it's critical to have the most up-to-date U-boot or bootloader, so that it's critical to have the most up-to-date U-boot bootloader. So that's first. Second is to boot using the micro SD card, using an image that you can grab from gumsticks.com. And then finally, there are lots of ways, and as I'm sure you all recognize, to build a web server. What I've done here is a little, perhaps a little tutorial, and put an Apache server on here running PHP as a CGI. So there are other really good, more lightweight systems for those of you who prefer programming in Python. Of course, there's a great Flask, and there's a Flask-ask module that you can do a pip install Flask ask. And in my case, I decided to use Apache. Then we'll do a responder script. I'll walk quickly through the highlights of the script that we've got running on in the demo. Then we need to add the endpoint and go back and build the skill at AVS using the ngrok that I'll walk you through how to fill in at Amazon the number that you get from ngrok in order to go forward here. So first things, the script highlights. Simple housekeeping, not all GPIOs may be exposed in the root file system as toggleable by the script, and so the first thing I do in order to get things going is to run a quick bash script. The way in which we'll see shortly, control the GPIOs is by opening them as with a file handle and in the sysclass GPIO construct. So the first thing that I do is make sure that all the LEDs are enabled. The distro has for 33, 34, 48, 48 all set up for export. These all control different LEDs, but 49 isn't. 49 is a green LED, and so I export that at the beginning, and then make sure that the permissions are correct. And then I start up Apache. The Apache runs PHP as a CGI in is it user share Apache CGI bin as index.php. So the first thing we do is we grab the header, and PHP makes that easy to grab as file get contents from standard in. And then there's a JSON decode, which I can then find exactly what was passed by Apache ASK using these object parameters. So, and when we take a look at the test, we'll have a quick, I'm not sure that came in, but we can take a look. There is a way to examine exactly the structure of the JSON requests from the Amazon console that makes it easy to debug whether or not you've called out values and keys correctly. So we grab the header first, then we do our action, and this is simply switch on action to, I've eliminated, snipped out, the other set value and clear value for the LEDs. But we open sysclass GPIO. GPIO pin is something that I've figured out from both value and color, but cleaned up to make sure that it's states GPIO and then digit only for values that are only for these particular values, 3, 3, 4, 8, 9, and then open it for appending. And then a switch on the whatever the action was that was sent to me. In this case, the example is toggle response text. So this is something that gets sent back to Alexa for Alexa to utter to whoever made the question. And then we just toggle 6 times, so the light goes on and off 3 times. And then I close the handle. And then after I've done the actions that were requested by Alexa, I send back a response. This is the response that indicates that it was done, and you can see here my response is output speech, and I'm sending text response text. And then at the end, I issue the response encoded in JSON again, content length. I need to include a header, the break after the header, and then the response, and then I flush it. I was never quite able to debug how the JSON, how the headers were properly controlled, and the key to get this working for me was actually to send it back as HTTP 1.0 instead of 1.1, so that this was not sent back as a keep alive session. That's it. This is really the meat of getting the Chatterbox to do something when Alexa asks, and then subsequently tell Alexa what to say after it's done. The next thing, now that so just take as given at this point that we have started up Apache, and this is running as index.php on the Chatterbox behind a firewall. We now need to instruct the Alexus Skills Console how to send a request, an instruction or a request or a skill to this endpoint. And so what we do is take advantage of something called ngrok, and this sets up a tunnel from, well, it sets up an HTTPS tunnel that is available that you can publish back to Alexa. And so first things first, download ngrok, and in this case, download and install the zipped ARM binary, and put it in your whatever file you're going to run it in. And what we do, trying to think, there was one glitch. We have not got the unzip working cleanly, and so something to remember is to download it to host and then SCP it up to, and SCP the unzipped binary onto your target Chatterbox. And then once they're, once you're logged in to your account at ngrok, you need to run ngrok, get an authorization token, and then you can pound this into the Chatterbox in order to get it up and running. And then in order to start your first tunnel, in fact, to start every tunnel, every time you instantiate, or every time you boot up again, you need to start a new ngrok and then copy the new public secure address over. So ngrok HTTP 80. Let's go to the next page, and what that will do is we'll set up this in a session, and it will provide you with HTTPS, and then you can see in the right here, it provides a forwarding address that you can then post directly into the endpoint page. Right here we are back at the Alexa Skills Console. In endpoint, you can publish, so you provided the HTTPS access here. Then you need to save it and then build it. Once all that's, and it takes a couple minutes to build the Alexa skill and have it deployed, something will pop up. And then once it's built, it'll pop up a message saying that it's built successfully. Once it's built, we can go into a test mode right here, which allows you to test the skill. And here we get a good example of, so this is an image of the Chatterbox right here that we've got. There's on the test page, after you've built it, built the skill, on the test tab here, you're able to either hold down the microphone and speak to this. You don't use a wake word, or you don't need to use a wake word. Hold this down and either ask it directly into your microphone on the host, not on the Chatterbox, on the host. And what you can say is, ask my Chatterbox to set the red light. And this is what we did here. And you can see that it sent, this is the JSON that it sent out. Remember, there's, you know, further down here, there is the request, and the JSON structure that you saw gets posted to headers that we interpreted from the standard in, and this is the returned from the Chatterbox. If you're having difficulty actually talking to it and getting read, you can type it in here and make sure that you test a number of alternatives. Okay, step 3. Step 3 is the Alexa voice services, and what we're going to talk about here is running the SDK. What we've done in here is built a standard AVS demo app, and we built it from the instructions at AVS. It is not for the faint of heart. You know, you need to know how to build and compile, so build and make. And many headers need tweaking, and allow yourself 2 days, possibly 3 days of slogging through building it from scratch. The instructions are very good and easy to follow, but it takes time. What we have got is we will have a downloadable version that's part of our setup kit. That does not include the wake word feature, but it will be available to get going. So to build this with wake word, you need to there are 2 available wake word technologies that are designed on both Alexa and the company's side. One is from a company called Sensory, which is the one that we've demoed here, and the other is from a company called Kit.ai. And those need to be managed separately, as they are separate. It's separate code from Alexa. We plan in the next couple weeks to have available a Yocto repo for the AVS device SDK to make this a simple, smart install. It's not supported in Yocto at this point. And then finally, you need to go to the AVS console and get a secret key pair. I'll go through a couple pieces of important point at that. Remember, at the beginning there were 2 tabs to get started on. One was Skills Kit and the other is Voice Services. Now you get started with the Voice Services, and you need to input what the device is that you're building. Here we cover the AVS device SDK into your source folder. It's available at GitHub. And again, the instructions are available for building it locally on your Colibri Chatterbox. The critical thing is really getting the secret key pair done. You can see that when you get to the Alexa Voice Services page, there is one product identification page where you need to put in product information. You will be assigned secure keys and codes. And then the security profile, you need to, in this case, what we've done is a Chatter demo profile demonstrating the Chatterbox. It'll provide a profile ID, which we've obfuscated, actually blanked out here and obfuscated here. We ended up getting a client ID and secret, which need to be loaded back onto the Chatterbox. And then right down here, it's important to identify allowed origins and allowed return URLs for the first time you boot this, so that you can go through this authentication. And this is, yes, your local IP address. Okay, now quickly, we've got a very simple demo showing this, this long process finally coming to fruition in something very simple. Here we go.
Alexa, tell my Chatterbox to set the red light.
Okay, I turned it on.
Alexa, tell my Chatterbox to clear port 34.
Okay, I turned it off.
Alexa, tell my Chatterbox to toggle the blue light.
Were you watching?
That's it. A lot of work for that simple demo. But if we jump back to the script highlights, I included this one particular piece. It toggled it, and were you watching is how it was the message that got sent back. So last here, what I'd like to do is do a quick demo of what to do with Chatterbox. What we showed was a simple Chatterbox is a nice simple system which provides a USB host, Ethernet, wireless speaker, etc. to do a demonstration on it with some buttons and whistles. But it's very likely that you would want to include additional functionality in anything you took to production. So in this case, what we're going to do is do a quick jump from quick jump to the actual source Geppetto documents and make some customizations in Geppetto. Just to highlight what Geppetto is a free online design tool that ends up delivering to you production quality boards in 3 weeks. It includes not just the hardware that gets delivered, but documentation and a board support package. It gets it ready, truly ready for you to take it to production. So what we're going to do here is I'm going to click on this, and this is going to bring up another window. Okay. So now we're taking a look at the window that just popped up when I clicked the link there. I'm going to grow it, open. Okay, so this is the Chatterbox, and if we click on our 3D view button up here, we can see that this is the same device. The value, zoom in, I'm going to zoom out. If we look at this, we see a workspace right here. We see a collection of modules and functions that are on the right here, and we've got tools along the top. So I'm going to make one simple change here. I'm going to say that we've decided that we don't actually want to have wireless. Imagine that. We're not going to put wireless on. So I'm going to delete that module and say that instead of having wireless on there, what I'm going to do is add some sensors. I will put this is an Internet of Things, so I'm going to put a barometer on there. And I'm going to say I want that to be on an I2C bus. I'll put it on I2C2. And let's see we would like a passive infrared motion sensor thrown on here as well. So I'm going to click that around so that it's looking in the right direction. I need an output. I'm going to send the output on GPIO, and then I need 3.3 volts. I actually dropped that. Let's see. Temperature sensor, here we go. I2C, an alert. There we go. So we've got now a barometer and a temperature sensor on here. I'm going to save it as Colibri iMX7 changed. And as soon as I do, it'll give me a chance to show you that there are those two new modules that we put on. I'm going to save it. And up here, I can click on this Auto Doc button, and it'll download documentation for me. And I'm going to need to, hold on just a moment here. I'm trying to set this up so I'm showing the right screen. Back to preview. So here's the documentation that we provide automatically, and it's available for anybody to take a look at freely. So this is included as part of the free services. So in fact, you can imagine that somebody could in fact input a design and end up with this customized even without ordering the product. And it includes a list of what modules on board. But the really key thing is to identify all the different connections that are in the system. And you can see here that it identifies everything. And then jumping way down to the end, we see that it constructed a module graph that highlights that the Toradex connector goes to the temperature sensor and the barometer. Those are what we just added in. And then here's the power graph to understand how much power is being used and drawn by the system. So that is of some value to people designing a system. The other great value is this piece here called the Auto BSP, which provides an automatically downloaded board support package for this. And again, this is on another file, so I'm going to bring that up separately. Okay, so in my folder, you can see this was the download, and we've got a Colibri iMX7. And it's a boot sector, device tree, and then a README that tells you exactly how to do to make use of this. Oh, the README you don't see. Sorry. So there's a README that describes how to do this, but also it provides the UENV that goes in at the device tree, and then you're able to download the Yocto image directly from gumsticks.com. Okay, and I think that's it. I forget the really critical point, and that is that once you've designed this, you know that you can download for so it's a $2,000 manufacturing fee, and it'll be $103.73 per unit, and we'll ship it to you on April 11th, completely functioning. And in volumes, gets down to $90, and that's with all this functionality. The Toradex Colibri is sold separately. Daniel, thank you very much for letting me highlight the system here, not just the Alexa, but to jump into Geppetto as well.
Yeah, thanks a lot. I think that's quite interesting, especially for people familiar with system on module. You have to do the carrier board, and I think that's a very simple way to do carrier board. So yeah, now we are open for questions. So feel free to type this again in the question box in your chat window, and I will pick them up and try to answer it, or Gordon is answering this. So the first question is, so is it possible to buy the Chatterbox off the shelf? So I think you showed that you can customize it, and you showed the fees like 2,000 and then per piece. But if somebody's okay with the off-the-shelf Chatterbox, is it also possible to buy that, or do you have other boards which work with Toradex modules you can buy off the shelf?
Yes, let me just jump to Toradex. So the Toradex boards that we support are now on the screen. We've got an iMX7 development kit, a development board on its own, and then the Chatterbox is off the shelf, available for $140. Yes.
Okay, thank you. Let me read here next.
There is a link in the I understand in our chat bot here that highlights the Toradex. What is it? Toradex Chatterbox design. I'm looking for the headline on it. Chatterbox product page. Yeah.
Yes. So if you look at the chat box, you can find most of the links we were talking in the webinar. And then, I mean, we had several questions. Is this webinar recorded? Yes, it's recorded, and we will provide you the link to the webinar download in the email a few days after this webinar. Is Geppetto a BCB tool?
A BCB, what does that mean?
Yeah, printed circuit board tool.
Oh, PCB
Sorry, my Swiss accent here.
It is a fully integrated system design tool, not just PCB.
Okay.
So we end up producing custom circuit boards, yes, but you don't get a PCB out of this. You get a fully integrated, assembled system.
Is it possible to import the output of Geppetto in another tool?
Right now, no, it is not. When you say the output of Geppetto is actually, we ship the boards. The auto doc is a PDF, so that's usable as instructions. The auto BSP supports runs on the device. So, some of the output is, but we don't export, for example, Gerbers or bills of materials as a part of our standard process.
Okay, thank you. And the hot word detection, is it running on the main core or on the M4 core of the iMX7?
The way we compiled this demo code is on the main core, not on the real-time core.
Also, maybe here a comment from my side for the people not too familiar with the iMX7. So the iMX7 is actually a heterogeneous multi-core. So you have the main core, which is a Cortex A7 or even dual-core A7. And then you have an extra core, an M4 core, where we can use for example, a real-time task. We have a nice demo with a robot you may saw, or it could also be used for low power tasks, so in IoT. So you could, for example, switch off the main core and then detect sensors with that M4 and then react if something happened. And I guess that would also be possible with for key hot word detection, but it's not implemented here. Okay, here are kind of similar question than before. If the schematics are available, if taken through a preliminary production run. So I guess if somebody really did the boards and everything and then want to ramp up, can they get the schematics?
So I guess what doesn't come across is that we do ramp up with Geppetto. So Geppetto is a production tool. It's excellent for prototyping, but the whole point is to go to production using Geppetto. What we've shown are pricing in small lots. There are quotation processes to go through for optimization for large volume production. So, that's not something that's available on a 15-day spin, but when our customers end up in production, we do offer, production level pricing.
Okay, thanks. And then here two similar questions from two different people. Is there a directional microphone array And how many microphones can be supported?
Not yet. There will be. Not yet, though.
Okay. So for the moment, there is one microphone, but it can be planned to be extended in the future.
Yes.
Same question, will an iMX7 mini platform coming soon? So maybe I take that.
Yeah.
I mean, there are three main line of iMX7. So there is the iMX Quad Max, which I showed on the first slide, which is a very high performance system with two A72, four A53, M2, M4s, and a big GPU. And then there is the iMX8M, which is currently available too, but Toradex did not do that module yet. So we're considering that for later, but we were not in early access. We were in early access for the iMX8 Quad Max and the X. And the iMX8 Mini would be a variation of that iMX8M. But honestly, I don't think that's going to be available from anybody very soon. So iMX8M, there are solutions not from Toradex for the moment, and 8M Mini, I think you have to wait a little bit. And what we do at Toradex is the iMX8X, which will be in the Colibri form factor, and that will be available this year. So I think that could be very interesting. This features up to 4 Cortex A35, so very power efficient 64-bit. Okay, so somebody, it's not really a question, but somebody maybe wants to work with you to integrate a microphone array to that, and maybe combine that with a carrier wall from Geppetto. I think that's interesting. Just write so just write the email to me or to Gordon. Actually, we didn't share the email address. My one is very simple: daniel.lang@toradex.com, which I also put it in the chat.
And I am Gordon, Gordon, at gumsticks.com.
About keywords, is there a limitation on keyword, or so probably can they use any keyword, or do they need to be careful, or what's the recommendation?
So that is something that gets encoded in this, either the sensory or kit software, and I recall that one of them has a broad range in the demo, the other has a limited range in the demo, and I've forgotten which is which.
Okay.
But there are more keywords than just Alexa available. That fundamentally, yes, but I'm not sure that it's not something that we've probed at all.
Okay, so would you know if I can have my own company XY as a keyword?
Yeah, so I think that's available, but I don't know whether it's kit or sensory that provides that, and we can find that out.
Okay, yeah, maybe short from my side, I know a little bit kit.ai, and I think they have a crowdsourcing way to create keywords, so you can create your own one. And then, I mean, it's a deep neural network behind, so you have to train it. So you have to say it many times. And if you only say it yourself, it will work very well if you say it. But if you ship it to the customer and he maybe has another accent or very deep voice or high voice or says it a little bit strange, it doesn't work so well. So there you can actually go on their website and select words and just say it, and then you also see different hot words or keywords or wake words, however you want to call that, how well they train or how many samples they have, and of course, as more people use a word, as more robust does it get. But that's just from one company.
Yeah.
Is there a cost using AVS?
No.
Yeah. Good, simple, good question. Always like to get that if something is free. Good. Let me check again. I get everything here. Okay, I think I'm more or less through. Otherwise, maybe repost it, and I think we will wait a few seconds in case anybody else has a question. Otherwise, you have our emails. You can call up Toradex in any offices, or you can call up Gumsticks if you have more questions about this. And as mentioned, the webinar will be available. Links we showed will also be available, so you can easily get actually that and reproduce it for yourself if you like.
Great. So I'm looking down a list of questions here that I've got. WakeWork, how can we integrate our own source code, do other tasks? I think we showed how to integrate source code in the script that I showed online. It's completely programmable, and something can be done on command from Alexa or in the background as any other process. Next question was, do we sell boards as an OEM? Both Toradex and Gumsticks sell our boards to OEMs for use in their products. That is each of our core businesses. Do we offer additional service such as flashing own Yocto built image? Yes, absolutely. Do we offer fulfillment to end customers? Yes, absolutely. As you can see, the Chatterbox product page at Gumsticks, for example. And we do handle order returns. This is, Toradex and Gumsticks have each been in business for, we're in our 15th year now. So it's a long time, and we have handled all aspects of the supply chain for industrial customers. Product packaging, we do have a partner, Protocase, that does handle product packaging. More often than not, our customers are working with a design firm and end up tooling their own systems. And that covers it. Those are all the questions that I'd had.
Okay, very good. So let's see, I didn't get any more in the meantime. So I think with that, we conclude that webinar. Thanks a lot for joining us, and check also out our other webinars. We have coming up one with Sierra Wireless about, this goes direction IoT, how to connect your board with LTE and to the internet. And then we have another one coming up soon. I think it's not even on our website yet. It's about industrial automation with MV Tech, so camera vision, and how you can use our models for industrial automation. Okay, thanks a lot of all, and have a good day, evening, morning. Thank you.
And Daniel, thank you very much. Bye-bye.
Thank you.